Good morning and once again welcome to my YouTube channel, Maths with Ease by Mr. Kamotho. And in this video I want us to explain example 2 of graphs 8 where we're still dealing with gradients. And we are told that a dog is running in a straight line away from its owner. Part of the distance time graph, and it is good to know that we are talking about distance time graph, describing the motion is shown. This is the graph. Describe how the dog's speed varies. I will talk something about speed. And part B, estimate the dog's speed after 30 seconds. To start with, you can see on the y-axis we have distance, and on the x-axis we have time. And there is some point to note here. Remember that the gradient of the distance time graph gives the speed. The gradient of the distance time graph gives the speed. It gives the speed. So in this case, we are in part A. We are expected to describe how the dog's speed varies. And from here, we can already see that from A to B, the line is straight. It has no gradient. That means there was no speed. And that means the dog was stationary at a point which is 10 meters away from the owner. So we can easily say A to B, or rather AB, A to B. The dog is stationary. The dog here, the dog is stationary. It is not moving. It is stationary 10 meters away from the owner. 10 meters away from the owner. The dog is stationary. It is not moving. But if you look at the same graph, from point B to point D, a curve starts forming, and the gradient at B is not the same as the gradient at this point, is not the same as the gradient at C, and it is eventually not the same as the gradient at D. And we can say from point B to C, there is a curve. There is a curve there. It's a curve. It's not a straight line. There is a curve. There is a curve. And what does the curve mean? The gradient is gradually increasing. Between point B to D, the gradient is gradually increasing. What does this mean when the gradient is gradually increasing? This means that increasing, meaning that the speed gradually increases, meaning that the speed of the dog gradually increases. The speed of the dog gradually increases. And of course, the dog continues to move from D to E, but you can see from point D to E, as you can see, there is a steep straight line. There is a steep straight line, and that means what? Here there is a steep straight line, meaning that the gradient is constant, it's not increasing. The gradient is there but constant. The gradient is constant. And because we said the gradient of the distance time graph will give you the speed, meaning that the speed is, the speed of the dog, the speed is constant. Constant at what point? Of course, if you calculate the gradient of the line DE from D to E, and there is no point of drawing a tangent because it is a straight line, you can just create a triangle from 30 to 60. The rise is 30. From this is 30, and this is 60. The rise is 30, and the run is from 40 to 60. The run is 20. So you can see the speed here, the speed between D to E is the gradient, which is 30 out of 20, which is 1.5 meters, 1.5 meters per second, because that is the rate, 1.5 meters per second. And that is how we can answer that part A of the question. But look at part B of the question. Part B of the question is saying, estimate the dog's speed after 30 seconds. We need to go back to the diagram or to the graph to establish where do we have 30 seconds, or where do 30 seconds end? This is 10, 20, and 30 seconds. So we are expected to establish or to estimate the speed of the dog after 30 seconds, 10, 20, 30. At this particular point, that is where we are supposed to establish or to calculate or to estimate the speed of the dog. What do? It goes without saying, and because at 30 seconds we have a curve, the only thing we can do is just construct a tangent at point C, and I would want to construct that tangent at point C that way, a good tangent that touches what? A good tangent that touches something like this. Let's see. A tangent at point after 30 seconds, and we can establish it that way. That is it. If we could talk about a triangle of this nature, that is the tangent, then we can talk about the rise over the run. The rise over the run. And the rise is kind of like, let's say 28, and the run is like 30, 40 minus 4, that is like 36. That is like 36 from here to here, or 36 or 37 thereabout. So, this is part A. Part B of the question, the speed after 30 seconds is given by the rise over the run, and we have established the rise to be almost 28 over the run, which is like 36 or 37 or 38 thereabout. So let's talk about 28 divided by 36. We get almost 0.77. That is it, 0.77. If we say 28 divided by, let's say, 30 what? 35, we get 0.8. But in a nutshell, if we say this is from here, this can be 2 or 3 for that matter. It can be 2. And this is 40. So 40 minus 2 or 3 is actually 37, or thereabout, 37. So 28 over 37, 28 divided by 37, we're going to get 0.75, is equals to 0.756 or 76. That is the speed, which is meters per second. The speed of the dog at 30th second is 0.76 meters per second or thereabout. Remember, it will heavily depend on the accuracy of your graph and how you can be able to determine the rise and the run accurately. Otherwise, in future, we are going to learn perfect, very accurate method of calculating the gradient. But for now, this is the skill that you need to understand about drawing the tangent of the curve at the point of contact, and that is what we are calling the speed in case we are dealing with distance time graph. The gradient is always the speed. Thank you. Let us subscribe and let us meet in the next video.